Made some slides for section 1.3 on induction and deduction. Let's take a look here quickly. All right, that's the title, 1.3 Induction and Deduction. The general idea, once again, refer to the text, and that should be first and foremost. I won't have actually examples here. I have 20 in the background in the text, and there are in the exercises another 30. So those would be the things to take a look at here. All right, what's the general idea? The difference between inductive and deductive arguments is that inductive arguments are probabilistic. Deductive arguments have to do with necessary connections. It is the connections that matter. The question here, logic, is about how well the premises support the conclusion. We may be asserting or looking at whether or not there's a likely connection, that's in the realm of induction, or a necessary connection, and that's what deduction is about. It is not the content, the kind of subject matter. It's not about whether or not it's debatable, future versus the present. You might have some tendencies with those things, but that's not the core deciding factor or issue. All right, very important here is the third bullet point. Arguments can fail logically. That, again, is the issue here. Is the logic, the connection between the premises and the conclusion, what it's supposed to be? Yes or no? So inductive arguments are not defined as where the conclusion follows with probability from the premises. They're defined as arguments where the conclusion is claimed to follow with probability from the premises. And then as we go on in the class, quickly here in the next section, starting right away with this kind of thing, we take a look at whether or not there really is a probabilistic connection. Incidentally, our standard is going to be needs to be greater than 50%. Necessity, it's either there or it's not. We're looking for a 100% connection. Deductive arguments claim to have and can have, as you'll see, because of the logical words that we have, a necessary connection between the premises and the conclusion. Sometimes it fails to be there. Again, the subject of the class is to figure out when this is the case and when it is not. All right, standard for deciding between induction and deduction. First, I have looked for induction and deduction indicator words. These words, since it's the conclusion that's being claimed to follow probabilistically or necessarily, these words should be in the conclusion, and that's where you want to look for these things. Probabilistic words are like likely, probably, good chance, odds are. Deductive words, there's a full list in the first guideline on page 8. Take a look at that. Deductive words would be necessarily, demonstrates, proves, has to be, things along those lines. The first rule is most important here, and mainly what I'll expect you to know, but not only what I'll expect you to know. Sometimes you don't have a word telling you flat in your face induction versus deduction. Then you should keep in mind types of induction and deduction. So for more challenging problems, you would have to know if it's an argument turns on definitions or mathematics, for example, on the deductive side, or something about causation or an analogy or appeal to experts on the inductive side. Words common in deductive logic can be, when it's close, telling. These words, as we're going to learn in the class, are crucially if, and then, or, and, only, necessary, sufficient, all, some, and no in categorical logic, chapter 2. Those are the ideas. Again, take a look at the book. Actual connection, can be relevant. I say this rule trumps the others, but it can be difficult to know when it applies. The idea is if the conclusion does necessarily follow from the premises, this is the main application of the rules I say in the book, then we always say the argument's deductive, giving it its due. To know that, you got to know deductive logic to some degree. You're going to need to make your best judgment at this point and take it from there.